So now we're going to continue factoring the magic x. Here's another example where there is actually an a. Okay, so what we'll see here is that we have 12 out in front, and I need to multiply that by my negative 2 to get negative 24 on top. On the bottom goes my negative 5. So now I need to work through factors of 24 that multiply, or that add to be negative 5. So 12 and 2 won't work. 6 and 4 doesn't work. That gives me 2. And so I need to continue working on down until I figure out my factors that work are going to be 8 and 3. Because 8 times 3 gives me 24, and if I subtract 8 minus 3, that gives me 5. But I don't want a positive 5, so I actually need the negative to go on the 8. Negative 8 plus 3 is negative 5. So you heard how I worked through each of the factors of 24 to finally come up with my negative 5. And once you do that, you need to divide by, again, cancel out the exponent, 12r. So divide each of these by 12r. So now what you'll notice is that 8 and 12 can reduce. They both have a common factor of 4, so divide 12 by 4 is 3r. And the negative 8 divided by 4 is going to be negative 2. So my parentheses turns into 3r minus 2 for that first one. And then the second one, you can see they also reduce. We have 12 divided by 3 would turn into a 4r. And then the 3 divided by 3 is a 1. So that's going to turn into 4r plus 1. Okay. Now, if you don't actually reduce there, you're going to find out that your factors actually still have a common factor inside, and you aren't going to want that. So make sure you do reduce by dividing by that number, that a that's out in front, along with your variable here. Okay, so here's another example, but this time you have a negative a, and that's okay. But we take our negative a and we times it by our 12, and that's going to give you negative 36. And then on the bottom we have our 16. So now I have to work through what are my factors of 36 that give me 16. And the answer is going to be 18 and 2. Because 18 minus 2 is 16, and I do need one of them to be negative. Okay, because 18 times negative 2 gives me negative 36. 18 minus 2 gives me the 16. So again, that might take you a while to figure out those numbers, but once you do get there, you divide each one by cross out my exponent, negative 3x. So divide the negative 2 also by negative 3x. Now once I do that, I go ahead and reduce. The 3 goes into 3 once, and the 3 goes into 18 6 times. So that's going to give me negative x plus 6. And then on the second one, I divide by a negative, because the numbers 2 and 3 don't have anything in common, but I can cross out the negative signs, and that gives me positive 3x minus 2. So this will be sufficient as my final answer for this particular problem. A similar answer, or an answer that continues from here, is you can actually work with this front parentheses, and you can pull out a negative. I don't think it'll make a difference in the lab, but it's possible that it might. This has a negative x in front, and that's kind of weird. What you can actually do is pull out a negative from there and turn that into positive x minus 6. It might be a better answer. It's a little unusual. It's a little weird to have a negative sign in front of an x in the parentheses like that, but it doesn't make that much of a difference, and we can have our negative sign out in front like that. So either answer is fine. If you wrote this bottom answer and then the lab marked it wrong on a test, let me know, and I'll give you the points for that. Now in this problem we're going to factor some more using the magic x, but first we have to notice that there is actually a GCF, a greatest common factor, that needs to be taken out first. First of all, they all have a 2 in common. They all have an x in common, specifically the lowest exponent is x to the first, and they all have a y in common, and this y to the third is the lowest one. So the first thing I need to do is factor out a 2x y to the third, and then if I do that from each one, the leftovers will be the 2 cancels out here, 2 are left over. So I'd have x squared, the y to the third, I pulled it out, minus 48 divided by 2 gives me 24. I pull out 1x, so that means 1x is left here. I pulled out 3y's, which means 1y is left from that negative 48. And then I have positive 288. If I divide that by 2, I get positive 144. And then I pulled out 1x, so there's no x here. I pulled out 3y, so that means 2 of them are left, so y squared. Okay? So this is, it looked like a harder problem at the beginning, but it turns into one like one that we've already done. So now I have to do magic x with the inside, this trinomial here, where the 1 is my a, the 144 is my c, so if I multiply 1 times 144, I get 144. And then on the bottom I get negative 24. So that means that I need to figure out what multiplies by 144. It's positive, so they either both need to be positive numbers on the side or they both be negative, and they need to add to negative 24. Well, I'm thinking 12 times 12, and they both need to be negative, so this turns into negative 12 times negative 12. That gives me the positive 144, and they add to be negative 24. And I divide them each by the x squared here, without the square, so just the 1x, so divide each of those by x, and that's going to give me x minus 12 times x minus 12, and because they're both the same parentheses, I want to go ahead and rewrite them to be x minus 12 squared, because they're two of the same thing, and then I want to make sure that I do bring down my 2xy to the third as part of my final answer. So the answer from the magic x was the x minus 12 squared, and then I do want the 2x y to the third to be part of my final solution. Okay, so a little bit harder GCF inclusion in the magic x here, but it all works out okay at the end. So now we're going to apply the magic x in a situation where I've got a little bit of goofy things going on with my variables. If you look at the variables, I got to the 6th power, p to the 6th, and this p to the 3rd r, and then r squared. Well, what that's going to mean is that in my final parentheses, I always have half of this amount, this first amount, so it's going to be p to the 3rd in both of them, because when I multiply those together, it'll give me p to the 6th. And then I'll have half of the second amount, so this r squared, half of that would be r. Okay, so my final answer is going to look like that with some numbers in there, so I just wanted to work that part out before we jumped into the magic x. So it's always half of the amount of the exponent. Okay, so first thing I go into the x's, I take my 12 and I multiply it by my 5, and that should give me 60. And then on the bottom I get 32, and it's negative, because it was a negative 32 in the problem. And then I'm thinking then that 30 times 2 is 60, because I'm seeing it needs to add to 32. And they both need to be negative. Negative 30 times negative 2 gives me positive 60, but it adds to be the negative 32 I was looking for. And then I divide each of those, getting rid of my variable there, by 12p to the 6. So I divide each of them by 12p, without the 6, I'm sorry, 12p, and then I reduce. So I reduce this to be, 6 goes into both, so we get 2 and 5, so negative 5. So that first parenthesis is going to be 2p, and then we said to the 6th power earlier, and then minus 5, and then I want to put my r down in here, 5r. Okay, and then on the second parenthesis, we reduce this to be 6, because we divide it by 2, and this turned into a negative 1. So it's going to give us 6p. Oh, sorry, I said the last one was to the 6th. I meant to the 3rd. So let's change that to be 3rd. Okay, and 6p to the 3rd here, and then minus my 1 r. So I can put 1 or just 1 r, and that is my final answer. Okay, so again, I took my 6th that was there, I cut it in half to give me the 3, and then I took my r squared, cut that in half, and gave my r. So when there's variables, it's always going to be the first variable cut in half, the second variable cut in half, and then whatever the numbers work out to be from the magic x. So this is my last problem using the magic x, and you can see how things got a little bit more complicated here. I've got an m minus 5 and then this should actually be an m minus 5, not m minus 2. I apologize. They both have m minus 5s, okay, after I fixed it, of course. And what we want to realize is that this would just be the same as if I had 4 times an x squared minus 4 times an x minus 15. Basically, then we call this variable substitution. That's what it's written up here. Basically, what's happening is, instead of having m minus 5, I'm just going to say, well, that's the same as this other m minus 5. And so I can just replace them and call them x. So the first one's squared, the second one's not. And then it's just magic x like we were doing before. So let's treat it like that. If that was the case, I would do 4 times my negative 15. And so I put on top negative 60. On bottom I have negative 4. So then I work through my factors of 60. That will give me 4, and I'm thinking about 10 and 6. And so I need a negative 10 because when I add them I wanted to get that negative 4. So then from there I divide each of these by my negative 4x, because again you get rid of the square, and divide this one by negative 4x and reduce. And if I reduce, this will give me 5 and a 2. So if I divide each of them by 2, divide this one, oh, and sorry, this should also be negative divided by negative will turn in positive. So that'll turn into a 2x plus 5. In the second parentheses, if I reduce them by 2, this will give me 3 and a 2. So that gives me negative 2x plus 3. Okay, so the whole problem just turned into something simple that we've done before. And then once I get to this step, I actually have to go back and make it complicated again. Because x isn't really x in this problem. X, each one of these x's, is an m minus 5. So what I need to do is now go back in and say, well, x is really m minus 5, so I need to rewrite this to be 2 times x minus 5, or sorry, m minus 5, plus my 5, times negative 2 times m minus 5 plus 3. So you can see my x's turned into the m minus 5s. Okay? And then from there you just want to simplify as much as you can. And you simplify by distributing the 2, and that gives you 2 m minus 10 plus 5 in this first parentheses. And in the second parentheses you would distribute the negative 2, and you get negative 2m plus 10 plus 3. And then you further simplify to get your final answer of 2m minus 5 times negative 2m plus 7. So a little bit of extra work required, especially at the end, but you can see how the first part over here on the left hand side was all just like what we were doing before once I replaced the m minus 5s with just an x. Okay? And then at the very end you substitute the x's back with what they originally were, which was the m minus 5, and just simplify to get your final answer, which was here. So again, sorry if you're still looking at this 5 here, that it was supposed to be a 5 when I wrote the problem. Somehow my finger slipped and hit 2. So good luck with these problems, and let me know if you have any questions. You can email me using the Ask My Instructor feature of the lab.